Hi, welcome to this aircraft simulation tutorial where I'm going to show you how to add inertial properties to your aircraft model, and this will mean that it will respond correctly to forces and gravity. So what we're going to do is add a rigid body component to your model, which enables us to set the center of mass and the overall mass of the aircraft. We're going to add a collider, which defines the physical bounds of the aircraft, so it defines what it does when it hits things and also helps define the moment of inertia. Something about physics materials, so what happens when you get contacts, what happens there, how you change that with physical materials. And lastly, we're going to look at verifying that the dynamics of the model behave correctly under gravity and when you apply forces to it. Okay, so here we are in the aerospace group design test environment, and what we're going to do is add our blocky plane that we made in the last tutorial. So if you go to assets in the project folder, you should be able to find your blocky plane, so exactly as you did before, and if you just drag that into the environment, there it appears at position 0, 0, 0, so that's actually the center of the world there, and it's just appeared in the center of the world. And what I'm going to do first, just to tidy things up, if I right click on it and go to prefab and then unpack, what that does now, it makes its own instance of that object. So this thing down here is a kind of prefab plane, so this is now one instance of this plane and then the scene, just to keep things nice and tidy. The other thing I'm going to do is that the actual plane graphics is this great long thing here of writing. This was generated by SolidWorks, and I'm just going to do a kind of slow click on that and rename it to graphics. And one of the things you just have to be a little bit aware of if you're dragging things around, if I select the graphics and I drag it, it just drags that bit, it doesn't actually drag the plane. So it's a little bit tedious sometimes, but if you want to drag the whole plane, you have to drag the top level of the hierarchy. So when I'm dragging that, it'll drag the whole plane up. So what I'm going to do is just pull the plane up in the sky a bit. And what we want to do is just test with no physics applied to that thing, nothing should happen. So it's just in graphics, and if we run the simulation, nothing should happen. And what I want to do is actually see it happening in the scene view rather than the game view. So when you press play, actually it jumps to this game view. And what I'm going to do is make sure that this little tab here, it starts off saying play focused, and what you need to do is change it to play unfocused. And what that means is when you press play, it just stays in the scene view, and it's less disorientating because things are going to jump around. So let's just check our setup. Our graphics is at 0, 0, 0 relative to the datum, and our blocky plane datum is, let's just be exact here, let's put it 2 meters above the ground. Okay. There's nothing else on here, so if we run the simulation, in theory nothing should happen. Okay, so success, nothing happens, nothing should happen, and nothing has happened. So what we want to do now is to make this respond to physics in the world, we need to add what's called a rigid body to it. So at the top level of the hierarchy of this thing, what I'm going to do is click add component, and you can start typing rigid, and it comes out pretty quick, and then select on rigid body. And this thing here it has mass and various different other things, but this is kind of the gateway to all the physics in Unity. So once you put rigid body on, so this object now will respond to physics in terms of forces, accelerations, gravity, and so on. What do we need to know about this? There's a few things on here. It's got angular drag, we can ignore that for now. Automatic center of mass, automatic tensor. So the things you need to know about the mass properties of an object are where its center of mass is and what its inertia tensor or inertia matrix is. And center of mass is fairly straightforward. This inertia tensor, basically it's the moment inertia on all the different axes, and if we just actually click not automatic, you can see it's set by, that's essentially IXX, that's IYY, and that's IZZ. You can change the orientation of it, but we don't need to. So when it comes to the dynamics of an aircraft, the inertia on the different axes makes a big difference how it responds dynamically. Okay, so we've got a mass of 1, gravity's on, so now if we run it, Brilliant. Okay, so just fell down under gravity, went straight through the floor. It had no knowledge of the floor being there, so why should it have done anything? Just went straight through the floor. Our next step up is to put what's called a collider on this, and a collider has two functions really. What it does is it defines the outer bounds of your models in terms of, as the name suggests, colliding into objects, but it can also be used for automatically calculating or estimating the moment of inertia, assuming kind of uniform density of your body. And that's a good start. It's not good enough for accurate flight dynamics, but this will get us going. So what we're going to do to put a collider on, I need to go down to graphics because it's going to use the graphics to generate the collider. I'm going to do add component, and I'm going to do, it's going to be a mesh, and it comes out pretty quick, it knows what I'm doing, a mesh collider. And you can have a mesh that's fitted over everything, but that's not very good for dynamic work. What we're going to do is a convex one, and what that does is just fits the sort of the tightest elastic bounds it can put around something. And if we tick that, making sure that gizmos is on, like that, clicking F to zoom in, and what you can see there is this green kind of box spider's web around the aircraft, and what Unity has done is just fitted the sort of smallest shape it can around the object, and that, when it bumps into things, that's the contact surface, and also it will be using that to estimate the moment of inertia. Okay, let's step back a little bit and press play. And there we go. So our aircraft falls to the ground and bounces. That's because we've got physics in terms of forces and gravity, but we've also now got this collider which says something about what the aircraft can move forward and through. Okay, so now what we're going to do is apply some forces to the aircraft. So if we go to the top level of the aircraft model, what we're going to do is add a force component. So if you start typing force, it finds constant force, that's the one we want. And we can apply forces in world coordinates or relative forces in the coordinates of the aircraft. And for us, the aircraft one is most interesting because that's generally how you apply forces in the real world. We can also supply some torques in a similar way. Okay, let's run that. So aircraft hits the ground, and let's apply a relative force in the y direction. And given that this thing weighs 1 kilogram, it should take 10 newtons, so the units of this is newtons. 10 newtons, it should start to take off. And there we go. So we've got our basic ability to apply forces. Bring that to lower, so it's going to hit the ground. Okay. Find it again, skidding over there. Okay, so our plane's upside down. Tell you what, let's try and flip it around the right way. So if we want to apply a torque, we can apply a torque on the x-axis, and that should flip it around. Oops. Okay, and that was lucky. Great, we're back the right way up. So we can apply relative force to the side, and that'll move it sideways, backwards and forwards, and so on. And lastly, okay, let's just make it do a spin. So relative torque y is green. If we do that, we can make it spin round. Okay, so what we got there is a material that's got a reasonable amount of friction on it, and when you apply physics material to these colliders, it tells you how things move. What we're going to do now, kind of just for fun, is put a low friction material on this, and then we'll set up a camera to look at the plane, and then we'll just send it off over the edge of the world as a send-off. So let's do that. Pressing stop, going to find my plane again, selecting it, pressing F, there we go, to find my plane. So what we're going to do is change the material, and if you go to Assets, Aerodynamic Objects, Demo Resources, Materials, you should find something called Low Friction Material, and what we can do is just drag that on there And now if we look in the collider, we can see we've got a low friction material. And what we were doing there before was we were watching this in the scene view. For most of your experiments, you probably need to set up cameras and things to see what's going on. So we're going, so you need to be able to switch to game view and use cameras for that. So first off, we're going to make game view active by doing play focus. So that means it's going to come on there. But then we also need to set up the camera. And we've got a ground camera set up. So this arrow man here has basically got a camera essentially where his head is. And if we go to the cameras in the scene view, we've got a ground camera there, and we select the second one of those. You can see it says target, and basically it says none there. So what we need to do is get our blocky plane and drag it into there, and it's found it transformed. So what it means is now the ground view camera is going to be looking at the plane. And you can leave everything else the same. If you've got gizmos on, you can see there that white box there is basically the camera view, and then the view in here is what that camera is seeing. So it's going to be looking at the aircraft as it goes along. Let's just check that works. Okay, so if you now notice the camera sort of follows the plane and goes on the ground. And okay, let's send it. So back to our blocky plane, spinning around ever so slightly. But if we time it right, if we apply a relative force in the Z direction, just make sure it clears the box, it should shoot off. Nearly there. Okay, let's go for it. There we go, shoot off our plane. Disappears over the world. Okay, and that's about it really. So what you've seen in this tutorial is that you can bring in a graphics object, which is just a dumb graphics object that doesn't do anything. As soon as you add a rigid body component to it, it suddenly now starts responding to gravity. It will still go through other objects, and to make it interact with other objects, you need to put a collider around it. And that collider also determines its moment of inertia. And then you can see that if you apply forces to your body and torques, it behaves as expected. And then lastly, just in terms of getting used to the environment, we've seen how we can use a ground camera to look at our object, so when it shoots off out of the scene, we can carry on following it.